Hey there, figured Keith needed to make an appearance in the video. He won't move. If I move him, he comes back. All right, so I'm going to show you how to set up an Excel. I'm going to do a video on each one, so it's not a big long video. But this one I'm going to show how to do a proportion. What I did here is I just double clicked on this tab and then I typed proportion because I'm going to actually have a spreadsheet for each one of these. What's cool is if you use Excel, then you're able to just reuse this same example over and over. So I'm looking over here to the left because I'm looking for that X sort one, okay? And so that's kind of the key to using Excel is, well, one, if you're not putting the formulas right in your calculator, that might be causing you problems. And I can show you how I put it in Excel is how you put it in your calculator. And two, why not just build one spreadsheet that will do every proportion hypothesis testing in the world? That's what I'm going to do. All right, so this, if you go back and you look at the slides, this started around slide 16, module 3, said we had 58 girls out of 100 babies. And so we know that means our p hat equals 58 divided by our sample size. Notice you saw me click on these cells. You're going to see why. I'm going to reuse this stuff. Everywhere I put a formula, let's highlight it because that would tell, well, I tried, that would tell me don't mess with this cell because that has a formula in it. All right, so this is, in fact, let's call it P null, right? Because that's the population right there, P. And they give us this 0.5. How do you find Q? Equals 1 minus that value. Don't forget every time you do a formula in Excel, you have to do the equal. So I hit enter. That's a formula. Can't touch that one. So let's put that there. All right, so now how do I find my Z value? Well, I'm just going to look over here and bring it over here a little bit. I'm just going to copy this formula. So this is my Z test statistic. I see that I want it to do the numerator first, so let's do an equal. I'm going to put this in parentheses so it does the numerator first. P hat, click, minus P, click, close my parentheses. Okay, so that's all good. Divided by, now I want to do the denominator, which is the square root. Open a parentheses. I want it to do the top first, the P times Q, so I'm going to open another parentheses. P times Q, clicking on the cells again, close the parentheses, divided by my sample size, so I click on the N, and then I close my square root. So the parentheses are important. If you're not putting parentheses, this might be why you're getting the wrong answers, and this is how you'd put it in a calculator as well. You have to force it to do the numerator first and then do everything in the square root and the numerator first and then divide. I hit enter and you can see that's exactly what I got from slide 18 if you look at the slides. All right, this one said to use a 0.05 alpha. So if I want to do the p-value, and some of you are starting to notice that the p-value is a little easier to interpret than the critical value. So a p-value is looking up 1.60 in the table, basically. But I'm too lazy to go find that table. So what I'm going to do is equal norm.s, and Keith's going to scratch, he has an itch, .inv. And now it asks me for my probability, so that's not the right one, .dist. Okay, so I'm going to use the INV for the one below. So norm.s.dist, open up parentheses. It is asking me for my Z value, comma, and it's always true. That just says add all the area up to that value. And I get this. If you remember, that's not the p-value we got. Well, what this is if my hypothesis was less than. If you go look, my hypothesis is really greater than. So that's okay. I can do this same thing. All I have to do is 1 minus that value. Okay, because remember that would give me to the right, the greater than side. All right. So it depends on, and here we got formulas, so we need to start highlighting stuff. I forget to do that. That means don't click in these formulas. So this would be if your your alternative hypothesis is less than. This would be if your alternative hypothesis is greater than. What if it's a not equal? I don't think I can do a, well, I think I can, but I won't. I'll just put not equal. Well, remember, a not equal would be 2 times this area. Okay, because if you think about it, that's giving me the area to the right, the cutoff on the right. Well, I need the area to cut off on the left. So that would even be if I had a not equal. I don't in this case, but that's what it would be for, right? All right, so right now I can see this question was a greater than. So I compare this with the alpha. I can definitely see, not a lot, but the probability is greater. So the probability, remember the p-value is, what's the probability you would reject the null? I'm not going to reject the null because it's greater than my cutoff. If they give me something like 0.10, then I would reject the null, right? But so I don't. All right, let's say you prefer to check your test statistic with your critical value. That's just another way, right? Another method. Well, to find the critical value, you do equal norm dot s dot, I almost messed up again, inv, and then you put the probability in there, and I close my parentheses. And notice in this case that this has given me a negative. So I'm checking, let's color these different because I'm checking, that's too dark. I'm checking this cell against this cell. Well, the problem is, once again, that's given me to the left. So that would be, let's just do the same thing here. That would be, what if that was a less than? Well, if it's a greater than, then what I have to do is equals 1 minus this value, dot s dot inv. So I actually want, I'm sorry, my 1 minus in the wrong place. I want 1 minus that alpha, so 1 minus, so 1 minus 0.05, which would give me my positive. And as you can see, they're the same number. And I hope that you're getting that because our normal distribution is symmetric. The area to the left is going to equal the same area as the area to the right. If this was a two-tail test, okay, so might as well just go ahead and create a formula for it, right? Then we would do equal, rm dot s dot inv. We would take our probability and divide it by 2. Okay, so that gives me this value right here. And the only thing you have to remember is with a not equal is it's plus and minus, right? So what I could do is I could say it's the absolute value. Do you remember absolute values in math? Just basically says take that number and make it positive. This is, I don't have to do this, but this is to remind me that a not equal cutoff is a left tail and a right tail, and those would be the cutoffs. All right, so once again, we found our test statistic. In this case is a greater than test. It did not fall in the critical region here, okay, is not greater, and which was the same as our p-value. All right, so what's the big deal, Cindy? Okay, this is great. This took a long time to type. Watch this. Open your book to page 401 and look at this example on computer programs. And it says here that we are going to test, we have, 380 out of 400 computers. Watch this. 380 out of 400 computers. My null hypothesis is 0.93. Look in the book where they got the test statistic. Booyah! So in other words, you don't have to keep redoing this stuff over and over. If you flip the page over, look what they got for the p-value. Booyah! Because this is a two-tailed test, right? And so this is the beauty. If I could get students to love Excel, Don't hard code numbers in, because now all I have to do are these cells here, and you might actually want to highlight the ones that you type in. These cells are the only thing that I would change. I could go take my quiz right now. That quickly work a proportion problem just by changing those numbers. So I know this is a lot if you're new to Excel, but I think if you pause and try to recreate this same spreadsheet, oh, you're going to love it. You're going to love it. And you're definitely going to see when we get into module 4, you got to use Excel, okay? Because the formulas are just too big. So have fun with Excel.